Hello, and thank you for joining us today for Frost and Sullivan's latest webinar from our Tech Vision practice. Today's webinar is titled Top 50 Disruptive Technologies and Innovation You Need to Know About. Multi-billion-dollar technologies transforming our world and creating new growth opportunities. Let's wait for another 2 minutes for others to join in the webinar. Hello again, and thank you for joining us today for Frost and Sullivan's latest webinar from our Tech Vision practice. Today's webinar is titled Top 50 Disruptive Technologies and Innovations You Need to Know About. Multi-billion-dollar technologies transforming our world and creating new growth opportunities. My name is Hannah, and I am the moderator for the day. Before we begin today's briefing, I would like to go over a few housekeeping notes. This presentation will be available immediately on demand, and you can view it at the conclusion of the briefing. We encourage you to ask questions throughout the presentation, and you can do that by clicking on the Ask a Question button. You can also safely share this webcast at any time by clicking on the Share button within the player. We will have many detailed slides on this presentation, so please feel free to use the full screen feature located at the bottom right-hand corner of the presentation screen. You can return to normal view at any time by pressing the Escape button on your keyboard. Finally, before you leave, we encourage you to leave any feedback or ratings under the Ratings button. Anand Subramaniam is the Vice President with the Tech Vision Business Unit of Frost & Sullivan, and he is based in Chennai, India. Mr. Anand manages the group's consulting and is also responsible for providing the business unit's syndicated reports to clients. At Frost & Sullivan, Anand has focused on engagement and issues that deal with evaluation of emerging technologies and business models, their impact on market trend and the firms that operate within it. Prior to his current role, Anand has experience in technology information research, including work as an analyst, project manager, and technology market consultant. He has written multiple research reports, white papers, and technology articles that have been published in global research journals and prominent business magazines. Without further ado, let's start the presentation. Over to you, Mr. Anand.
Thank you, Hannah, and hello and good morning, good afternoon to all our ladies and gentlemen. I'd like to thank you for tuning in to today's presentation. I will start my talk about Tech Vision's flagship service, the top 50 emerging technologies and new convergence opportunities. The future of the future, navigating an innovation-driven world. Can you go on to the next slide, please? So the top 50 business unit leverages technology innovations and disruptions and convergence that drive transformational growth. I am excited to share some very interesting work that my team in TechVision is doing in the field of emerging technologies, innovations, and technology convergence. So before I jump into the presentation, I would like to define the context of today's briefing. So TechVision is the technology IP, innovation, and convergence focused group. Our analysts all around the world are constantly engaged with technology clients focusing in innovation and emerging technologies and covering an entire gamut of research and development that spans across government-sponsored research, R&Ds of companies, research institutes, research incubation centers, non-government labs, not-for-profit organizations, and certainly the corporate sector such as small firms to large corporations. So what you see here on this screen is we cover 9 different clusters such as information communication technology, medical devices, microelectronics, sensors and instrumentation, advanced manufacturing and automation, chemicals and advanced materials, energy and utility, environment and sustainability, and health and wellness. We believe that more than 90% of the world's technologies and innovation can be mapped in this 9 technology cluster formats. A fairly comprehensive coverage, and all development nicely ties into several vertical industries that you are now viewing on your screen. So about 8 years ago, we set up a mission to develop the top 50 technologies with 2 main objectives. One, to scan the technologies and use a specific methodology to come up with an annual list of top 50 technologies that are likely to impact our lives in the next 1 to 2 years. And number 2, to look for convergence scenarios where 2 or more of this list of 50 technologies could interact with each other to create innovative and possible disruptive business models for tomorrow. So our organic and continuous research work in researching technologies across clusters, geographies, across industries led to the top 50 technologies and convergence scenarios. And this is interesting to share with all of you, the 2018 edition. Next slide, please. So we are entering the era of X-Tech. What it means, the buzzwords today are FinTech, EduTech, Agri-Tech, and so on. Emerging tech-driven disruptive innovations are fueling new business models. So now let me go a little deeper to cite examples of innovations that we are witnessing within. Basically finding killer applications to disruptive innovation. Some of the technologies that you are seeing on the screen include zero friction, self-healing materials, smart water grid, microbiome, collaborative robots. All of these are gaining prominence and acceptance. If I pick up self-healing materials, well, its innate ability to heal itself upon physical damage have the potential to replace existing materials used in various industries. Self-healing as a technology becomes critical to extend the lifetime of structures, protect capital-intensive assets, and reduce downtime, be it machinery or industrial structures. A unique feature about self-healing technology is that it can be incorporated in existing materials as a coating or an additive to make existing structures self-healing in nature, or use self-healing materials, mostly as polymers, to manufacture machinery, infrastructure, automobile paints, offshore and onshore structures, and so on. While the technology is being adopted as paints and in the automotive industry, In the healthcare industry, we are seeing potential applications as self-healing bandages. Its use in mainstream industries such as oil and gas and manufacturing sector is still nascent. However, these industries are the future focus of many technology developers in this space, including companies like Autonomic Materials, Viscotac, NEI Corporation, and Covestro. The technology has gained the interest of many in the OEM space in the oil and gas space, according to the research that Frost & Sullivan completed recently. The next interesting technology that I would like to touch upon is on zero friction surfaces. Although the science of interaction between any two surfaces does not allow for zero friction, a surface treatment and a coating process that can reduce the static and dynamic friction down to near zero levels could solve problems caused due to abrasion, stickiness, or adhesion from various substrates. The development of zero friction coatings and surfaces tailored to meet key specifications and key application prospects such as automotive, food and beverage, marine, packaging can be potential alternatives for existing coating technology. Major chemical and materials manufacturers are actively looking for product development partners to improve technology feasibility and quicken time to market. Adaptive Surface Incorporator and Liquid Glide in the US are key innovators working on liquid impregnated surfaces to eliminate dry friction. Also, the Department of Energy, the National Institute of Material Science Japan, and Oregon National Laboratory are attractive research partners in this domain. Smart water grids. It's believed that global water utilities observe almost 30% of non-revenue water rate due to leakages throughout the water grid. With global urban population soaring to a new high, the need for saving and distribution of high-quality water through superior quality water infrastructure is increasing. This challenge can be immediately addressed with the incorporation of smart water grid-based technology, which focuses on real-time monitoring on water quality, quantity, and leakage. Smart water grid consists of sensors, smart meters, and other smart water supply and distribution equipment which can monitor quality and quantity of water. Recently, installation of smart water systems in over 300 water distribution systems in US and Canada has resulted in an annual saving of $12.5 billion. This is possible due to better leakage management and precise water quality monitoring. Dubai Energy and water authorities aims to reduce water consumption by 30% in 2020 by installing smart water infrastructure. Smart water solutions in Queensland, Australia have helped authorities to prevent losses of 6.5 billion liters of water. So what you see here are major structural changes that are happening and newer business models that are evolving as a result of this. Next slide, please. Thanks to the technologies, ladies and gentlemen, we are living in a fascinating world in a very incredible point of time. It's only going to get a lot more exciting in the next few years. That is likely to bring radical changes to the world. Our carbon footprint is to change, dependence on fossil fuel is likely to change, and a lot of different innovation is likely to happen. So let's come back to the day. So we took this scenario of technology-driven, fast-moving world and tried to apply it to our work on a day-to-day basis. So we wanted to identify the technologies of the future. So we created an engine called the Innovation Serendipity Engine, which looks like a kaleidoscope. So we started with a whole host of technologies that are spread across 9 clusters. There are likely hundreds of technologies within each of these clusters. We evaluated each of them. We overlaid them with the lens of megatrends. We wanted to see which technologies drive which megatrends and vice versa. This gives rise to new business models that companies may be driven to apply, such as co-creation, gamification, freemium, and others. And then, of course, we added a dimension of market, which is which technologies are going to be adopted by which market. And finally, we had another layer of another innovation ecosystem drivers, which included the academic institution, funding agencies, government labs, evangelists, and users. So we wanted to see the impact of these 5 different sets of independent variables. So this is a kaleidoscope that comprises of different combinations. So if you could see it, it depicts ICT, innovating to zero, big data, healthcare, and end user. So end users are demanding personalized medication with 0 defects, 0 accidents, 0 breach in privacy and security. And that can be done using different business models in healthcare using various kinds of technologies. So one can create a lot of combinations with the innovation serendipity engine. Next slide, please. So our first step was to get the 50 technologies. So we literally started with hundreds and more of technologies. We evaluated them on a technical basis, and we wanted to go beyond that and look at it from a funding and market potential and IP point of view. So we identified 6 criteria, weighted criteria, and we applied a mathematical model to all these technologies. So that gave us a sub-construct. So we put all of these technologies to a stress test. We added another criteria called the year of impact, mainly to get to know when these technologies are likely to be adopted for mass commercialization. So a combination of those that we are able to cull gave us an innovation index. So if you're ready, they're all featured randomly under each of the 9 technology clusters that you are going to see in the next slide. Next slide, please. I wish I had the time to take you through each of these technologies, but I thought that for this brief presentation, I will pick up a couple of technologies as examples for this session. Some technologies that you are looking here are obvious: advanced batteries, 5G, blockchain, and a few surprising ones, such as small data. Small data analytics refers to targeted data mining. It involves capturing the basic information of specific attributes that control the current state of an entity within a connected network. Small data is about analyzing microdata that exists in the system. Interesting, isn't it? What you see under medical devices is stereotactic surgery. It is a minimally invasive surgical procedure which involves the use of medical imaging and 3D modeling to precisely identify surgical targets to operate upon. This approach is particularly useful for robotic surgeries, obtaining tissue biopsies, or operating on sensitive target organs such as the brain or the spinal cord. The way we visualize this on the universe is 50 stars, and each has its own ecosystem. Each technology in itself has a lot of opportunities. The most interesting aspect is the white space it has between these technologies, and that's where a lot of convergence happens across these technologies in the future. So we also picked up some very interesting signals within this universe of these technologies. The total market potential of these technologies is almost $2.8 trillion in the next 5 years. About 200,000 patents have been awarded over the last 3 years, which gives an indication that these are prime targets for commercialization. About $120 billion was spent in R&D. So they all pack a punch. With that, I would like to elaborate some of these technologies to give you a perspective about what we inferred from some of the top 50 technologies. Next slide, please. Cognitive security, developing intelligent security systems for prevention against cyber attacks. Let me give you some key facts about this. The World Economic Forum has listed cybercrime as the top global risk for businesses in 2018. 98% of companies operating globally have experienced malware-based threats in 2017. Over 200,000 computers were affected globally by WannaCry ransomware attacks in 2017, and over 1 million computers still remain vulnerable. The British consultancy Cambridge Analytica illegitimately accessed and used personal information of around 50 million Facebook users in the 2016 US elections. So why is cognitive security important? A cognitive security system outthinks and outpaces threats with security systems that can understand, reason, and learn. It briefly refers to the use of cognitive technologies such as artificial intelligence, machine learning, and natural language processing to make sense of security data that has previously been unanalyzed by an organization's defenses. This enables security analysts to gain new insights and respond to threats with greater confidence at scale and speed. Cognitive systems have the ability to recognize natural language and make connections between data points that a security analyst may never have considered. Social platforms, including Facebook, now use cognitive systems to flag posts from people thinking about harming themselves, including the ones contemplating suicide. Some key application areas related to cognitive security is this could widely be used in user behavior analytics, identity and access management, and data security. Next slide, please. Some of the key companies that are working in this particular space include the ones that you see in your screen. Specifically, Spark Recognition's cognitive approach to endpoint protection is to integrate machine learning and deep learning technologies. Their Deep Armor analyzes the DNA of unknown files by breaking them into small components to check the malicious nature. Blue Vector's threat detection platform leverages machine learning technology to detect, analyze, and classify malware. Their architecture allows the platform to run several detection engines in parallel, resulting in accuracy of almost 99.1%. RSA's security and behavior analytics solution has helped more than 30,000 customers to thrive in the world of cyber threat. The solution uses statistical and machine learning techniques that speed up cyber threat detection and helps the security analyst to respond to attacks and threats in real time. Next slide, please. We are talking about the world of advanced batteries. Metal ion and metal air batteries are appropriate alternatives for lithium ion. The 2-year period from 2018 will be very important for researchers and commercial stakeholders to help the end users realize the importance of battery technologies other than lithium ion. This period will also be crucial in determining the future of these post-lithium ion batteries. Some of the important post-lithium ion solutions include lithium air batteries, which are considered as the next big thing of rechargeable batteries. Although their technology readiness level is still low, their theoretical specific density values are approximately 16 times more than that of lithium-ion batteries. This means that they present an opportunity to increase the operational time by a factor of as much as 2. In terms of solutions with most promising commercialization capabilities, Frost & Sullivan research identifies that sodium ion and lithium sulfur have better chances of adoption. These two technologies are better poised to reach the necessary technical maturity levels for commercialization. Next slide, please. The innovation ecosystem for advanced batteries involves stakeholders across the value chain, from raw material producers to battery packagers across regions. Even though startups, predominantly university spin-offs and research institutes, are dominant in the US, growth in Europe is also promising. In Europe, announcements regarding battery megafactories are expected. It is important to note that Asia Pacific is still a force to reckon given the number of megafactories already present in the region. Some of the key areas of research and development focus on developing suitable materials, which are very important in making the batteries suitable for supporting faster charging capabilities, providing better energy and power density capabilities, and also in making them safer. Development in materials used in electrodes, electrolytes, and phase of electrolytes have led to promising solutions with improved safety and storage capacity. For example, Innovate USA has developed a high energy density battery which uses anodes that are based on silicon, which offers lithium-ion cells up to 50% higher capacity than conventional graphite cells. Interesting. Let's move on to the next slide. We picked up a few areas, and this is related to our health and wellness technology cluster, microbiome. The technologies that are poised to transform the global healthcare landscape. We see an exponential rise in microbial research, and growing industry interests will facilitate groundbreaking microbiome-based innovation across pharma, personal care, and food sectors. This will help restore, of course, natural microbial balances in humans, thereby improving overall health and wellness. Emerging innovators such as Vedanta and uBiome are looking to develop microbiome-based therapies for gastrointestinal diseases. S-Biomedics is looking towards the skincare space for introducing revolutionary microbiome-based platforms. And Azitra may lead the future of genetic engineering platform for microbiome-based solutions in the future. Next slide, please. The probiotic innovation lead the global microbiome landscape according to our analysis. The US is likely to lead therapeutic applications across the microbiome landscape, while Europe will emerge as one of the leading players for innovative microbiome technologies that will find groundbreaking applications in personal care and food and beverage products. Companies such as Char Hansen will lead the probiotic landscape by developing scientifically robust probiotic strain with scientifically proven health benefits. Innovative companies like Azitra are likely to develop novel genetic tailored microbial platform for disease management. Brain health will be the future focus area for microbial technologies. For example, Calliope, another innovative startup, is focusing to use microbiome platforms for gut-brain axis applications. Next slide, please. So as part of the exercise to draw up the top 50 technologies, we also looked up at the exhaustive list of technologies that were part of the long listing of technologies and came out with some of the technologies that are likely to have an impact in the 10 to 15 year time frame. We picked 2 per cluster and came up with findings about what technologies are likely to garner interest in the future. So what you see here are some of our picks, such as neuromorphic chips, power to X, DNA data storage, self-reconfigurable modular robots. These are interesting technologies to watch out for, or for potential R&D investment related strategies. Next slide, please. We also plotted these 50 technologies on a scatter diagram that you are now viewing to get the market attractiveness of these technologies. The strategic opportunity matrix that you see here, this gives the analysis on 4 sets of variables such as IP, market potential, innovation index, and adoption across different industries. So what you see here are our picks related to biomarker assays. The platform will drive convergence and new business opportunities across pharmaceutical and diagnostic industries to fuel groundbreaking innovations in precision medicine. Cancer biomarkers have already garnered significant interest across the global research, clinical, and regulatory landscape. This trend is likely to spill over across other indications such as lifestyle disorders and neurodegenerative diseases. The other interesting technology is on hyper-imaging analytics, which gains prominence beyond healthcare and surveillance applications into food, agriculture, mineralogy, and environment monitoring. Future development are likely to create opportunities in enabling armed forces to detect chemicals and biological threats, and in assisting clinical healthcare staff in performing non-invasive surgeries. With the advent of Internet of Things and connected ecosystem, data is growing rapidly and is becoming an integral part of evolving IT infrastructure. The latest trend in the data analytics space is to uncover granular details about the business impact from every data set connected to the enterprise network. The next generation of data analytics will be able to consolidate these small data clusters to improve efficiency in big data analytics process. Next slide, please. This slide shows the technology attractiveness matrix. This gives the analysis on funding and IP of the 50 technologies. Biobetters are suitably poised to replace biologics that are likely to go off patent in the short-term future. Biobetters are likely to lead transformative change in medicine. The rising popularity of blockchain is due to its ability to increase trust by combining cryptography and decentralization. Companies are building their own blockchains across industry sectors such as fintech, energy, transport, logistics, insurance, and governments. By providing a simple, secure mode of transaction, both financial and non-financial, thereby simplifying the movement of money, goods, and data worldwide. So they pose an attractive investment for tech-related strategies. Next slide, please. The market attractiveness matrix, this gives a 5-year market potential of the top 50 technologies plotted across applications in 23 different industries. What we saw here is deep learning enables intelligent automation of workflows and business processes, which are driving higher levels of efficiencies and transformation. The fundamental way of doing business in almost every sector globally is going to have the backbone of deep learning. The future may soon be one where humans and computers move from being separate entities to becoming a single cognitive unit. The other attractive technology here is nanohybrids, which has the ability to enhance performance characteristics and provide added functionality to an end product, and is poised to impact countless applications across all major industries. The wide portfolio of materials, coatings, and nanoparticles helps in addressing application-specific requirement of industrial and consumer sector. Next slide, please. So the message is a lot of potential across all the technologies and even better business opportunities if they are combined with each other. So that's the concept we call as the waves of innovation. And it's about leveraging convergence on each of these technologies. In this example, you see metal 3D printing, sensor fusion, and deep learning and artificial intelligence. We believe that this is an interesting proposition as they begin to converge and interact. And in the next few years, based on the IP interactivity emanating from these technologies, a whole host of products are likely to be embraced. Here you see that sensor fusion will be able to assess the failure of a component and will leverage AI-based deep learning program and supply information in real term of the probability of failure that will be picked up in a plant elsewhere, where a metal 3D printer will start producing these components and be in the supply line to replace the aging products. One underlying need for the industry is to ensure cognitive security is in place to prevent threats from malicious sources. So we came up with a few examples of convergence, which I thought I should share with all of you now. With that, we'll move to the next slide, please. Here is a convergence scenario. The converging technologies that we have captured include advanced batteries, mobile desalination, advanced encapsulation, microbiomics, and agriculture 2.0. What is the context for us to set this up? Since the early 90s, the importance of water as a precious resource has been recognized, along with the political implications of water sharing and scarcity. Several political and environmental commentators have made this comment often. The next global war will be fought over water. The facts: only 3% of the world's water is fresh and can be used for drinking, sanitation, and agriculture. Of this, only a fraction is easily accessible. On the other hand, cities like Cape Town, Chennai, Jakarta, and many more coastal cities around the world are located on the shores of great quantities of salt water that can technically be reused for farming and drinking. Simultaneously, indiscriminate farming and unsustainable agricultural practice have put a lot of pressure on arable lands, gradually lowering their yields and productivity. All this brings the focus to developing sustainable farming practice and at ways to improve crop yield and output. The TechVision Group has analyzed this challenge from a number of different angles and believe that a convergence of technologies which are being independently touted as being important and critical can offer a possible solution. So what is the solution? The convergence scenarios that we have named MAGA, or Make Agriculture Great Again, is well suited and is of great importance to geographies where the access to fresh water and poor land use has been affecting agriculture. We believe that mobile desalination plants can help convert large volumes of salt water into usable water for agriculture. Advanced battery systems using next-generation lithium-ion batteries can help power these systems even in areas that are remote or not readily connected to grid power, as is the case with most struggling agriculture areas. Colonies of bacteria present in the soil help plants absorb water and nutrients, improve immunity against diseases, produce yield and withstand climate extremes. Identifying and favorably supporting these microbes can help improve agriculture outcomes. In fact, pilot projects are already underway to examine the impact and performance of microbial coated seeds. Further, advanced encapsulation technologies can help in targeted delivery of nutrients to the plants, preventing wash-off. Encapsulation can help in sustained release of pesticides and fertilizers and increase bioavailability of nutrients. Next slide, please. This is the second convergence technology that I have picked for today's briefing, which is automated theranostics. The concept of automated theranostics is a convergence scenario that combines continuous and precise diagnostic tests and specific targeted therapies through a feedback loop. We envision that leveraging of biosensors in a lightweight wearable form factor that would continuously measure essential biomarkers in the body. The central information processing console would then analyze these metrics and trigger a drug release mechanism when the measurements are found to be at a mismatch with target levels. This would be a particular use in case where chronic illnesses should be monitored or when targeted delivery of drug is of utmost importance. The next slide that we have is a convergence scenario on the future of utility, smart localized power generation and management. Smart localized power generation has the potential to answer challenges like power intermittency and power outages and waste management. The localized energy needs can be met by the waste to energy technologies and other renewable means, and this will be supported by advanced storage technologies. Excess power can be stored and used during peak hours. The augmentation of sensor fusion and deep learning with the waste to energy solutions will help monitor the generations and parameters and provide preventive measures in cases of any anomalies. The generated energy can be distributed to other local consumers, and this energy exchange carried out of blockchain, and any excess energy can be exported back to the smart grid. So that concludes this particular briefing. The next slide, of course, is to let all of you know that innovative convergence drives solutions.
Thank you for insightful presentation, Anand. Now I would like to open the floor for Q&A session. If you have a question for our speaker, please type your question under the Ask a Question button. I also like to take this opportunity to quickly go over some next steps. We invite you to join our Guild Community newsletter. By subscribing to the Guild Community, you will be exposed to a fantastic flow of ideas, information, and best practice through our research, industry, and career-based newsletters. Or ask for a growth partnership discussion to give you a clearer idea of how we work with our partners to accelerate growth. If you like what we have covered but not sure what to do next, or if you would like more information on this briefing or services, please feel free to reach out to us at asiapacific@frost.com. Your feedback is important to us, so under the Rate This button, please provide any feedback, comments, or suggestions on today's presentation or on our webcast program. We also encourage you to follow us on any of our social media sites listed on this slide to keep up to date on upcoming analyst briefings and research. Again, if you would like to ask a question, please type it under the Ask a Question button. Also, a gentle reminder that an on-demand recording of this briefing will be available immediately following the presentation. We would also like to extend the opportunity to you to engage in a free growth strategy dialogue with our experts. For more details on this topic or on any Tech Vision reports, please contact Anand S, whose details have been displayed on your screen. Let's get started with some questions now. We will take as many as we can, and those we weren't able to take now, we'll be taking it offline. So Anand, our first question from the audience is, if we had to pick between metal air and metal ion, which one will it be? Will lithium ion maintain its leadership? Over to you, Anand.
Yep, thank you. Now, lithium ion batteries are of course expected to maintain their leadership in the battery energy storage space. And we believe that they will have the leadership positions for at least 5 years. Next generation lithium ion batteries that contain advanced materials, mainly silicon or 2D materials, will address the current challenges of charging time and safety. But what we are also seeing is that post-lithium ion battery chemistries are currently at a very low TRL levels. Although I had mentioned that they seem to have a very high theoretical specific density, which is 16 times more than the lithium ion batteries. In terms of solution, with the most promising commercialization capabilities that Frost & Sullivan perceives are sodium ion, which have a better chance of adoption. Yeah, next question.
Okay, sure. So we have another question from the audience. Why are we not seeing large-scale deployment of desalination plants to solve the water problem? Over to you.
Yeah, I think this is a very topical issue, especially now that we are seeing zero water cities emerging across different continents. One of the reasons for non-deployment of desalination plants is that it's a very energy intensive kind of process, and it involves a lot of capital cost, especially for large scale operations. And that's the reason we are looking up at mobile desalination plants if it's feasible. Many companies in Israel have developed good technologies. But having said this, the technology has already been used quite widely in the oil and gas industry. They also have a very high adoption potential in regions where we are facing a high water level stress, but low spending capabilities of some of the local governments. It's mainly the capital cost that is not seeing larger deployment. Yep. Any other questions,
Right.
Hannah?
Yeah, we have another question coming in. So our third question is, do we need to consider copyright issues for 3D printing deployment?
Okay. Copyright issues for 3D printing. 3D printing has seen a lot of development. Laws associated with copywriting, its deployment has struggled, of course, I think, to keep pace. Currently, there is no definite direction at which copywriting of 3D printing development will take place. It's very similar to what we had seen at the early part of this decade, when the music industry and the film industries actually faced a lot of copyright issues. So the concerns associated with copyright are going to have a very high impact on 3D printing deployment. It's very important to address the issue for the betterment of the industry. Multiple industry participants in 3D printing spaces are already kind of showing some amount of caution and are looking up at ways on how to protect the copyright issue with 3D printing. So that is my answer.
Okay. Thank you to Anand S for answering all the questions. Due to time constraint, we will have to close the floor for Q&A. If you have any question for our speaker regarding this webinar, please send an email to asiapacific@frost.com. This concludes today's presentation. We hope you found today's webcast informative. Feel free to contact us with any questions or additional feedback. Thank you and have a great day.
Thank you all.